You're good.
So, good afternoon. We are Group 3.
Today we're going to be talking about Chapter 11, Steel.
And we are Leslie, Joel, and Daphne. Hi, guys.
All right, so to go ahead and start off Chapter 11, prior to the beginning of the 19th century, metals actually had little structural role in buildings except only as connecting devices. So, they were only used as connecting devices, which is really, really interesting. Um, so, next we're going to be talking about cast iron. So, it's produced from iron ore in a blast furnace, and wrought iron is iron that has been purified by beating it repeatedly with a hammer. And these two types of iron were used increasingly for buildings in Europe and North America in the first half of the 19th century. Their usefulness was limited, however, by the unpredictable brittleness of cast iron and then also the high cost of wrought iron as well. So, what is steel? Steel is actually any type of a range of what's called alloys of iron, which is pretty much iron mixed with other substances that contain less than roughly 2% carbon. Too much carbon makes a hard but brittle metal like cast iron, while too little carbon produces a malleable, weaker material like wrought iron. So what's called mild steel is an iron alloy whose properties have been optimized for structural purposes by controlling these carbon amounts and other elements in the metal as well. So the process of actually converting iron ore to steel begins with the smelting of the ore into cast iron, which is what we talked about earlier. And then this is done in a blast furnace. Regardless of the particular steelmaking process, finished steel is cast continuously into what we call beam blanks or blooms, which are then rolled into final form. And this diagram right here shows the steelmaking process from which iron ore is created into structural shapes. From natural elements to furnaces, to molten steel, to casting, to final issues of structural steel, this process can be very, very complex. So by adjusting a mix of elements used in the production of steel, its mechanical properties could be manipulated. Mild structural steel, known as ASTMA36, may be specified for common shapes such as angles, channels, plates, or bars. And ASTMA588, or weathering steel, might be used where there's no protective finish and it is placed in an environment where it will remain exposed to exterior conditions. So there's different types of denominations for different types of steel with different purposes. So it's pretty cool. In some cases, the properties of steel are adjusted after the final shapes are rolled as well. So for example, another type of steel, ASTMA913, is subjected to a process of quenching or rapid cooling and then tempering, which is partial reheating, in order to give the steel a little bit more strength, toughness, and weldability as well. We're going to talk about welding a little bit later. So in the structural mill, which is kind of where all of the metal processing takes place, the beam blank is reheated as necessary and then passed through a succession of rollers that actually squeeze the metal into more refined versions of the desired shape and size. And then these segments are then cooled on a cooling bed. And then finally, each piece is cut to its appropriate length and then labeled with the correct designation. And then later, when the piece is actually shipped to a fabricator, it will be given the correct chemical analysis that it needs in order to meet standard specifications. So it's pretty cool because what we call families of related pieces of metal with the same nominal dimensions are produced. And this would provide architects and engineers with like a really, really appropriate selection of shapes. Okay.
Oh, fire! Oh my goodness! What's the procedure? What do we do, people?
The phones are dead.
Oh, how did that happen? Another option! Another option! Jeez! Okay, settle down, everyone. No
I
punching.
forgot my
Come on,
purse.
leave it, woman! Get out of the way. Go, go, go! Things can be replaced, Phyllis. People, human lives, however, can...
So as you guys can see, we just we just had a little
That
bit
happened.
of a yeah, that happened. We had a little bit of a fire drill, and I guess that's why it's important to have good steel in your buildings, right?
Fireproof steel.
Fireproof steel.
Yeah.
So yeah, we're gonna go ahead and continue with the podcast. I believe I left off on all of like the families of the steel shapes and how they can provide architects and engineers with like a really good selection of shapes for like each member in a building, which can also help avoid waste. So the actual shapes themselves are identified using what we call a standard nomenclature. So how it works is they begin with a letter for the shape, followed by one or more size, thickness, or weight dimensions. So it's letter then dimensions for each of those things. So for example, if you see MC 10x22, that is what we call a miscellaneous channel shape, which is what MC stands for. And it's 10 inches deep and it weighs 22 pounds per foot. So moving on to the nomenclature for what we call wide flange shapes, those begin with the W for the word wide. And so, for example, a W12x26 is a wide flange shape that's 12 inches deep and it weighs 26 pounds per foot of length. So moving on to rivets. Rivets are steel fasteners consisting of a cylindrical body and a formed head. And then as seen in part A, a hot steel rivet is inserted through the holes and the two members to be joined. In part B and C, its head is placed in the cup-shaped depression of a heavy handheld hammer. This hammer then drives the rivet sets repeatedly against the body of the rivet to form the second head. And then finally, in part D, the rivet shrinks as it cools, drawing the members tightly together. And then moving on to bolts, we're almost done with my part. The manner in which a bolted structural steel connection derives its strength depends on how the bolts are actually installed. So in any typical connection, bolts are inserted into holes that are 1/16 of an inch larger than the diameter of the actual bolt. And then often, hardened steel washers are inserted under one or both ends of the fastener. And then bolts are usually tightened using an electric impact wrench. In this diagram, you can see a high-strength bolt before and after it is fastened and tightened. Before is on top, and then after is on the bottom. And then finally, welding is another part of joining steel members, and it can join the members of a steel frame as if they were a monolithic whole. So they are stronger than the members that they joined in the first place. So in practice, welding is a complex science. The elements of the structural steel and the welding electrode must be properly matched. Here you can see the electrode creating a puddle of molten metal on the base metal, creating cooling weld metal to improve structural support.
So for my section, they started talking about lateral stability of a building frame. There is 3 basic lateral forces, and this system can be abbreviated as LFRS, and they are used either alone or in combination. The 3 basic lateral forces are braced frames, shear walls, and movement resisting frames. The brace frame uses diagonal bracing to create a stable triangular configuration within the framework of the structure. The shear wall are stiff, solid walls made of reinforced concrete steel or less frequently reinforced concrete masonry. The movement resisting frames rely on stiffer movement connections between beams and columns to impart lateral stiffness to the building frame as a whole. In any building, the lateral force resisting elements must be arranged in a manner that is structurally efficient as well as conducive to good architectural planning. For tall buildings, there's 2 structures. A core structure, which is a building's interior core or cores, which is also the central area continuing elevators, stairs, shear walls, vertical mechanical cases, and washrooms. The other one is tube structure, in which the lateral force resistance system forms a continuous perimeter around the frame. They also talk about shear and movement connections. And there's also 3 types of beam-to-beam connections, which are classified by the American Institute of Steel Construction, also abbreviated as AISC. The 3 types are fully restrained, which is FR movement. Connections are successfully rigid so that the geometric angles between members will remain virtually unchanged under expected loadings. They also mention partly restrained, which is PR movement connections, are not as rigid as the FR connections, but nonetheless possess the dependable and predictable movement resisting capacity that can be used stabilized to a building framing. They also mention how simple connections and shear connections are capable of unrestrained rotation and have negligible moment resisting capacity. There, as you can see in the screen, there will be 6 different beam-to-beam connections. There will also be 4 column splice connections. Continuing, they talk about the steel building frame, which is a process that starts with the rough sketch. Then it's moved into a structural drawing that shows location, shape, size, and load of columns, but doesn't specify the exact member lengths or voting connections. The fabricator uses design connections as bolting and welding based on the engineer's requirements. The fabricator also creates drawings for installing foundation anchor bolts and assembling the steel frame. Then the drawings are reviewed and approved by the engineer and the architect. Then the fabricator orders the steel stock for fabrication while the drawings are being approved. After approval, any necessary changes are made and templates are created for the accurate cutting and assembly. The steel pieces are cut, drilled, and marked with templates in the shop. The steel pieces are also labeled with codes for proper placement in the building, and the beams and the girders are cambered, and the steel shapes can also be bent and fabricated into complex geometries. For stiffer plates and connecting parts, they are welded or bolted to the steel components. And lastly, they are assembled in units to be ready for transportation to the construction site. They also talk about the erector. The erector jobs starts about after the fabricator is done. The erector is responsible for assembling into frame the building side steel components. They erect a first year, which starts with assembly on the first year of framing. The steel is lifted with the mobile crane and fixed or fixed tower cranes. The columns are picked up directly from the piles or the delivery trucks and are lowered to anchor, and there's iron workers that bolt them down. They also talk about the erecting the upper tiers, which is after the erecting the first tier, which is after the 2-story column section, and they are hoisted into position and connected by sling plates on top of the first tier of the column, extending above the working platform. They also mention the floor and roof decking, shallow arches or brick tile work constructing between support steel beams tied with steel tension rods and filled with concrete to produce level floor surfaces. This method is heavier than metal deck and requires larger framing members with intensified labor. But there's also metal decking, which there's 3 types, which is form decking. This is a metal decking that acts as form work only, and and the composite metal decking is designed so that once that the concrete has hardened, two materials beneath as unified element or composed floor slab. There is also roof deck, which is used without concrete topping, and there's cellular deck, which is made by welding a flat sheet to the underside of a corrugated sheet under during deck manufacture. They also mention beam construction, which is concrete is poured on metal deck and shear studs that are welding very few inches to the top of each beam, and this is using a specific electric welding gun. These studs interlock with the beam and concrete such as to act in a unified fashion. Concrete decks may be poured in place or over temporary wood or metal forms to create concrete planks that may be set in place. Other roofing deck, such as non-combustible construction, the steel decking is most prevalent roof decking material. In combustible construction, roof decks can be constructed of heavy timber decking. And lastly, they talk about architectural structural steel, which is steel that is exposed and can be specified as architecturally exposed structural steel, or AESS.
All right. And with that, we can begin with fire protection of steel farming. Normal buildings fires are not hot enough to melt steel, but they can be hot enough to weaken steel sufficiently to cause the steel to lose its strength and fail. Generally, limit the use of unprotected steel farming to buildings of no more than 2 to 5 stories in height, in which escape can be made rapidly in the case of fire. And right here, there's a chart illustrating the strength that steel has regarding the temperature it could get up to. For taller buildings, it is necessary to protect the steel frame from heat long enough for the building to be fully evacuated and the fire extinguished or allowed to burn out on its own. Fireproofing was originally done by encasing steel beams and columns in brick masonry or poured concrete. They work by absorbing heat into the great mass and dissipating it, some of it through the dehydration of the mortar and concrete. By their weight added considerably to the load that the steel frame had to bear. Plaster fireproofing has largely been replaced by beam and column enclosure made of boards or slabs of gypsum or other fire-resisting materials. These are fastened mechanically around the steel shape, and in the case of gypsum board fireproofing, they can also serve as finishing surface on the interior of a building. Here's a few examples of how these work. We have the concrete encase. We also have the concrete filled, and the one I was just talking about is the fire-resistant board enclosure. Where the fireproofing mat rail need not serve as a finished surface, sprayed apply fire resistance material, SFRM, commonly referred as sprayed apply fireproofing, have become the most preventable type. These products are available in density ranging from 12 to 40 pounds per cubic foot. The building with floors higher than 75 feet, 23 meters above ground, the International Building Code, the IBC, requires sprayed apply fireproofing with higher bond strengths to make it less likely that these materials will be dislodged from the structural members they protect in the events of unusual events, like the World Trade Center towers that occurred in 2001. Intumescent mastics and intumescent paints are thin paint-like coating that allows steel structures elements to remain exposed to view in situations of low to moderate fire risk. They expand when exposed to fire to form a thick, stable chart that insulates the steel and the heat from the fire for varying lengths of time, depending on the thickness of the coating and the weight of the steel member. And this is a picture of how that would look. Longer spans and higher capacity columns in steel. Standard wide flange beams are suitable for the range of structural spans normally encountered in offices, schools, hospital apartment buildings, hotels, retail stores, warehouses, and other buildings. In such columns may be brought to the earth at intervals without structuring the activities that take place within. Athletic buildings, some industrial buildings, aircraft hangars, auditoriums, theaters, religious buildings, transportation terminals. Longer spans are required than can be accomplished with wide flanked beams. A rich assortment of longer span structural advices is available in steel for these uses. The castellated beam, which there's a picture of right here, is produced by flame cutting the web of a wide flamed section along a zigzag or arcade pad, then resembling the beam by welding its two halves point to point, thus increasing its depth without increasing its width. With greatly arguments of spanning potential of the beam, provided that the superimposed loads are not exponentially heavy. Steel trusses are a triangular arrangement of steel members that are generally deeper and lighter than improved beams that can span correspondingly longer distances. They can be designed to carry light or heavy loads. Custom designed and fabricated roof trusses are light-loaded and traditionally made up of steel teeth and paired angle top and bottom cords with paired angle internal members. The staggered truss system relies on story-high steel trusses started on alternating floors of the building structure and spanning between the perimeter columns to support the floors and the roof. A steel placed truss or space frame is a truss made three-dimensionally. Arches. Short span steel arches can be made by bending standard wide flangle shapes or by joining sections of straightened members. Heavier arches are one of the longer span structure forms available in the building designer. Tensile structures. Fabrics and cables made of cold-drawn, high tensile strength steel wires are the material for fascinating variety of tent-like roofs that can span from short to very long distances. With anti-class saddle shapes, curvature, cable stays, and other means of restraining the cable net, hanging roof are fully ridged against uplifts or flutter. And here's a few examples of how that looks. With anti-class saddle shapes, curvatures, cables, and cable stays, and other means of restraining the cable net, hanging roofs are fully rigid against wind uplifts and flutter. The tensile fabric structure is a membrane supported by a mass or other grid structural elements such as frames or arches. The membrane usually consists of a woven textile fabric reinforced with steel cables along the main lines of stress. Pneumatic structures depend on air pressure and their stability and their capability of carrying snow and wind loads. Fabrics for permanent structures. The fabrics used in permanent structures are two general types: coated structures, fabrics, or polymer film. Tensile structures. Tensile structures are stabilized by anti-clastic curvature press stress, and anti-clastic curvature means that the fabric is curved simultaneously in two opposite directions. Press stress is the introduction of the permanent tension into the fabric in two opposite directions. Air-supported structures. Air-supported structures are pressurized by the fans that use to heat, cool, and ventilate the building. The fabric of an air-supported structure is press-stressed by its internal air pressure to prevent flutter. Composite columns. Steel and concrete can be combined in various ways to make composite columns. Sidecase reinforced concrete may be cast around steel wide flange columns, or steel pipe may be filled with concrete. Especially in tall buildings, large steel pipes columns filled with very high strength concrete may be used to carry large vertical and lateral loads. Like Joel mentioned earlier, similar to what we saw in Zaha Hadid's building. And with that, I finished my section. And I think with that, we finished chapter 11.
Yeah, I think that's everything. And I mean, even though we had like a little bit of an interruption with
Yeah.
the fire drill, you know, as
We're alive, so it's
Yeah,
all,
we're
it's all
okay.
good.
hopefully the Z building didn't burn down.
I don't think they even realized. They
don't
probably
think so.
the alarm didn't go off again.
Yeah, but no, I mean, as in Daphne's part of her presentation, how she was saying that fire can definitely not melt steel but weaken it. I mean, at
Yeah.
least we're all here.
It checks out. Building's all right.
Yeah.
They use the proper measurements, guys.
But yeah, that's everything from all of us. Thank you for watching our video. Bye, guys.
Bye, guys.